Take 72. Don't believe me about anything, guys. All right, so going to continue the idea with curved mirrors. So I've got one that looks a little different, but it's still a reflective surface. I've got one here, and then I have, of course, another one here, and you can clearly see the curvatures are different. One curves way more than the other. I'm going to use this little sheet right here. It's meant for an optics kit, which is the study of light. It's meant to kind of show the light rays on it, in this case the laser beams. I'm going to actually just use it for the little measuring stick right here, so we're in centimeters. Alright, I'm going to do actually the one that curves more first. I'm going to put the center of the mirror right at 0 the best I can. And if we continue that idea of sending in parallel light rays, it should actually then show us how far that focal length actually is. It's probably kind of hard for you guys to see, but it looks like it's approximately 1.6 centimeters. This one, because it has a much different curvature, I would expect its focal length to be different. So if I line this up at 0 and see where they meet, it's definitely different. It's actually a much longer focal length because it doesn't curve as quickly. It's going to be a bigger circle, larger radius or center of curvature, which is then larger focal length. This one ends up being about 2.7 centimeters, approximating that, okay? Alright, so keep in mind the curvature, which is basically how big of a circle it's creating, or how small, that's going to help you determine the focal length because it's based off of that center of curvature, which is technically the radius when you draw a circle.